In this lesson, we are going to learn about other mole conversions. So far, we have learned that you can use equalities to help you convert the units of a measured quantity, and most recently we were working with molar mass as an equality for just this purpose, where we knew that 1 mole of a substance was equal to the atomic mass of that substance if we measured it out in grams. Molar mass is the mass in grams of 1 mole of a substance. So that's what we've been using as our conversion fraction. But there are other conversions that we can do. And by the way, you will need your periodic table and a calculator. So other conversions that we are going to do is we are going to want to use the equality, excuse me while I sharpen my pencil, of 1 mole is equal to 6.02 times 10 to the 23 particles. So we have this equality where 1 mole is equal to the atomic mass in grams. We have another equality where 1 mole is equal to this many particles. And even though we haven't learned about gases, we can use a third conversion fraction where 1 mole of any gas at standard temperature and pressure conditions, and 1 mole of any gas will have a volume of 22.4 liters. You might be wondering what STP is. Well, if you look at our reference tables, we can see that standard temperature is 273 Kelvin, or 0 degrees Celsius. Standard pressure is 101.3 kilopascals, otherwise known as 1 atmosphere. So these are basically normal conditions. And that's what STP is. This is just essentially saying normal conditions. All right, so each of these equalities involves 1 mole. So we can keep track of it by keeping a mole map where the mole is at the center. So we're going to start with this map right here, and in the very center we're going to write 1 mole. Okay, because we have 3 different things that 1 mole is equal to. If we are talking about particles, we know that 1 mole is equal to 6.02 times 10 to the 23 of those. Okay, and by particles, we could be either referring to molecules, atoms, or ions. Okay. We have learned and have been working with molar mass. Right, so 1 mole of a substance will weigh its molar mass, which is effectively the atomic mass in grams. And that will help us convert to mass. So if you want to know the mass of something and you know how many moles you have, we're going to use molar mass as our conversion fraction. The third equality is 22.4 liters. 1 mole of any gas will have 22.4 liter volume. But this, of course, works for gases only. And it works only at STP conditions, which are normal conditions. Okay, so anything that is in a box, right, this box, or this box, the items that I have written in the boxes, these are going to be used as our conversion fractions. So I'm going to put this in a box with a little asterisk. Okay, so anything that's in the box, you're going to use that as a conversion fraction, because conversion fractions are equalities. And we have 3 equalities here. We have the equality 1 mole is equal to 22.4 liters of a gas. We have 1 mole is equal to the molar mass of a substance, which we would have to look up on the periodic table. And we have the third equality of 1 mole being 6.02 times 10 to the 23 particles. Okay, so we're going to use these equalities as conversion fractions to help us convert between particles, volume of a gas, and or mass. So let's take a look at some of those problems. I'm going to turn the page over. And we're going to put that mole map to use. In fact, what I'm going to do is rip it off so we have it side by side. Okay, so our first problem that we have here says how many grams will 4 moles of oxygen weigh? So we're going to also be working on best practices. When you see a problem like this, you always want to start with the given quantity. Okay, so we're going to start with the given quantity. And so we're going to start, and you're going to start all the way as far left as you feel comfortable doing. So I'm going to start 4.00 moles of O2. And I really want you to use best practices here where you are including the number with all of its sig figs. You're including the unit, in this case moles, but you're also including the identity of the substance. So 4.00 moles of O2. That's our starting quantity. Okay, make this all the way to the left. We're then going to set up a conversion fraction where we want this unit and this identity. This has to cancel out. So we're going to put moles of O2 in the denominator. Now, we are starting with a number in 4 moles, right? So we're starting with moles. So we're here on the map. We are given not 1 mole, we're given 4 moles, but that's okay. So we're starting with a unit in moles. We are trying to go to grams. That's mass. Okay, so we're going from here to here. So the conversion fraction I have to use is going to have 1 mole, right? So the conversion fraction always is going to be about 1 mole. And we are going to go to the molar mass of this substance up in the numerator. Okay, so we have to go look up the molar mass of O2. And in case you don't know or don't know this one off the top of your head, oxygen on the periodic table to the nearest tenth is 16.0. But it's O2, so we're going to double that, becomes 32.0. Okay, so we start our given quantity, right, had a unit. That unit is we're going to put it down here in the denominator. And we are going to go to our other unit up in the numerator. So moles of O2 over moles of O2 are going to cancel. And then we're going to have 32 times 4. And our answer is going to be 128 grams of O2. Okay. Sig figs. I started with 3 significant figures. I'm going to end with 3 significant figures. This conversion fraction has no bearing on your significant figures because it is an equality, and equalities are considered to have perfect number of significant figures. All right, we're going to skip down to question number 3. How many liters, that's what we're trying to find, are there in 4.4 moles of O2 at STP? So that just means normal conditions. So we're going to start with our given quantity, 4.4 moles of O2. We're going to set up our conversion fraction, and the unit we started with automatically has to go in the denominator. And we know that according to our mole map, whenever we have mole down here, we're going to go with 1 mole of O2. We're trying to convert it to liters, so that's going to go up into the numerator, liters of O2. And we know here that 1 mole of any gas will have a volume of 22.4 liters. Okay. Moles of O2 over moles of O2 cancels, and the math just becomes 4.4 times 22.4. Okay. Our answer here to 2 significant figures, calculator says 98.56, so we need to round that to have 2 significant figures. We're going to say 99 liters of O2. Again, you're reporting your answers. All numbers in these problems are going to have a number, a unit, and an identity. All right, let's take a look at question number 5. How many molecules, that's what we're trying to find, will be in a 3.00 mole sample of HCl? So this is our given quantity. We're going to start with that. 3.00 mole of HCl. So we're starting with a unit in moles, and we're trying to figure out how many molecules that is. So that's particles. So our conversion fraction is going to use 1 mole, and it's going to use Avogadro's number. So we're going to set up a conversion fraction. The unit we start with goes in the denominator. going to be 1 mole, is equal to 6.02 times 10 to the 23. We're using molecules as our unit here, of HCl. Canceling. Moles of HCl is going to cancel with moles of HCl. Our math becomes 3 times 6.02 times 10 to the 23rd. And we have 3 sig figs to start, so we're going to go to 1.81 times 10 to the 24 molecules of HCl. All right, let's go down and try problem number 7. Things are still going to be a little more complicated in problems 7, 8, and 9. Number 7, how many grams? That's what we're trying to find. We are given 1.8 times 10 to the 24 molecules of H2O. So let's start with that given quantity. 1.8 times 10 to the 24 molecules. There is no really good abbreviation for the word molecules, by the way. Molecules of H2O. Okay, so let's look at the strategy for this one. We are given molecules, that's particles, and we are trying to go to grams. That's down here. So that's going to be a 2-step problem. We're going to use 2 conversion fractions. The first conversion fraction will involve 1 mole being equal to 6.02 times 10 to the 23. And the second conversion fraction will be equivalent to 1 mole is the molar mass of HCl, or of H2O in this case. Okay. So let's start. Our first conversion fraction from particles to moles. We started with molecules of H2O, so we have to put molecules of H2O in the denominator. And we're going to go from molecules, which is a particle, to moles. Remember, it's always 1 mole. So 1 mole up top is equivalent to 6.02 times 10 to the 23rd. Okay. If I stop here, if this is the end of the problem, that's okay, molecules cancel, and I'm left with moles of water. Okay, but that's not what we're trying to find. We're trying to find grams. So all I've done is converted molecules to moles. Now I'm going to try to convert it to mass, which is grams. Okay, and that means I need 1 more fraction. I'm going to put moles of H2O in the denominator. Okay, it's 1 mole of H2O is equal to the molar mass of H2O. So the molar mass of H2O, we got to go to the periodic table. Oxygen is going to weigh 16.0 grams, plus 2 hydrogens, each at 1.0. So this is going to add up to 18.0 grams of water. So moles of water cancel with moles of water. And our math, I'm not going to do any intermediate calculation. I'm going to do it all as one chain calculation. And you could do this a couple ways, right? You could take this original number, 1.8 times 10 to the 24th, multiply that by 18, take that answer, divide by 6.02 times 10 to the 23. Or you could take 1.8 times 10 to the 24th, divide it by 6.02 times 10 to the 23, and then multiply that answer by 18. Does not matter. It's all the same mathematically. So 1.8 times 10 to the 24th, divided by 6.02 times 10 to the 23rd, and take that answer and multiply by 18. 2 sig figs to start, so I need 2 sig figs to end up with. This is going to round to 54. And the only unit that didn't cancel is grams of water. So here you can see that this problem that required 2 conversion fractions was because we were starting with particles and going to mass. If we were going from volume to mass, we would also need 2 conversion fractions. This is the first one, this is the second. If we were going from mass to particles, we would need 2 conversion fractions. Okay, so I'm going to not do these other problems. I think this is where you should try these other problems. Check with the answer key in your classroom And just stepping back for a moment, what we have done today is you have learned about other mole conversions other than just moles to grams. So far, this is the only one that we had worked on so far. But we can convert moles into the number of particles, or we can convert moles into the volume of a gas. Right? So that's it for this lesson. We'll see you back in the classroom.